It began with light, but not the kind that gives warmth or hope. No, this was different. This light came in flares, like silent screams across the dark, pouring from the mouth of something ancient and hungry. In the blackest reaches of the universe, a dead star had gotten too close to something no force can resist. A black hole. It tried to pull away, to orbit just far enough to survive. But the black hole had other plans. Caught in a relentless 9-hour loop, the star passed close again and again, and each time the black hole tore away more of it. Every pass stripped it of its dignity, its mass, its very self. And with every bite, the black hole grew stronger, heavier, more complete. One day, the star would vanish entirely, not in a flash, not with a bang, but in quiet defeat, devoured piece by piece until nothing remained. And this is the power of a black hole, not just the ability to consume light or stars or even space, but the ability to rewrite the story of anything that gets too close. So the question we all begin to ask naturally is this: are we safe? For a long time, Earth seemed blessedly far from any danger like this. But recently, astronomers discovered something unexpected: a small black hole, only 3 times the mass of our Sun. It's the smallest black hole ever found, and also the closest, only 1,500 light-years away. A cosmic blink. They call it the unicorn, not just because it was rare, but because it didn't fit what we thought we knew. Hidden in the constellation Monoceros, the unicorn quietly sits in space, watching, waiting, not moving toward us, not threatening us, but undeniably there. Black holes aren't like comets or rogue asteroids. They don't wander through space like predators. Most are stationary, content to feed only when something crosses their invisible edge. But then again, sometimes they do move. In 2021, scientists found something terrifying: a supermassive black hole hurtling through space at 177,000 kilometers per hour. That's not just fast, that's blistering. And they had no idea why. Even more shocking, that wasn't the fastest one. In 2017, another black hole was caught tearing through the cosmos at 7.2 million kilometers per hour. 7 million. No one knows exactly what made them run. But the best guess? A collision. 2 black holes slamming into each other with such ferocity that one is launched into space like a cosmic cannonball. Imagine that. A force so powerful it could move the unmovable. And yet, for all this power, all this hunger, there's still one question that haunts our dreams. What happens if you fall in? People love to joke that you'd be turned into spaghetti, or crushed, or burned. And sometimes that's true. If you got too close to a small black hole, it would stretch you like a string of atoms until you were torn apart. But if the black hole were big enough, say 30 or 100 times the mass of the Sun, you might survive the fall, at least for a while. Because here's the strange thing: a big enough black hole doesn't just stretch you, it rewrites the rules of reality. Einstein said gravity isn't just a force, but a curve in the fabric of space itself. And inside a black hole, space and time twist until they don't make sense anymore. Imagine this. You and your closest friend take a spacecraft to a black hole. One of you agrees to fall in. The other stays back, watching. As you drift toward the event horizon, the point of no return, your friend sees something unimaginable. You start to stretch. Your body warps, like being pulled into a funhouse mirror. And the closer you get to the edge, the slower you seem to move. You hover there at the very boundary, frozen in time. And then you burn. Not from fire, but from the heat of reality itself. A ring of fire called Hawking radiation licks across your body until there's nothing left. Just ash, just memory. But here's the twist. From your point of view, inside the ship, drifting toward the unknown, None of that happens. You pass the horizon like it's nothing. No fire, no stretching, no pain, just darkness. Peaceful, terrifying darkness. How can both things be true? This is the paradox that has haunted physicists for decades. You are dead, and yet not. Burned at the edge and still alive inside. One moment, two versions. A split in reality so deep it threatens to shatter our understanding of the universe. They call it the black hole information paradox. And it's not just a riddle, it's a warning that inside a black hole, the laws of physics stop making sense, that reality, as we know it, unravels. And maybe, so do we. We weren't ready for what black holes would teach us, not just about the universe, but about truth itself. For years, scientists believed black holes could erase information, that anything falling in, stars, matter, even light, would be obliterated, its story lost forever. But then Stephen Hawking came along and shattered that illusion. He proposed that black holes don't just consume, they evaporate. Over time, through a process now called Hawking radiation, they slowly lose mass. Faint, silent whispers of energy escaping their grip. A black hole can die. It just takes longer than the age of everything. But if they evaporate, where does the information go? It might seem like a strange question, but physics demands an answer. In our universe, information is sacred. It cannot be created or destroyed. So if black holes erase it, then everything we understand collapses. Causality breaks, time unravels. And maybe, so do we. It was a cosmic scandal, Einstein versus Hawking, logic versus the void. Then came a bold idea. Maybe the information isn't lost. Maybe it's not destroyed inside, because it never makes it inside at all. Some physicists believe that everything that falls into a black hole is copied, projected like a hologram onto its surface. That's right. Your atoms, your structure, your very soul spread across the event horizon like a photograph burned onto glass. To the outside world, you burn. To yourself, you fall. Two realities. One fate. That surface, then, isn't just a boundary. It's a library. A cosmic recording of everything it consumes. It's a horrifying thought that even as your body is shredded, your story is written into the skin of the void. That a black hole remembers everything it eats, forever. And yet, we still don't know if that's the truth. Because to test it, we'd have to get closer than anyone has ever dared. And for now, black holes remain silent. But the silence doesn't make them small. If you could replace our sun with a black hole of equal mass, Earth would remain in its orbit, unharmed. The sky would grow cold, life would vanish. But we wouldn't be pulled in, not unless we moved closer. That's how compact they are. A black hole the mass of our sun would be just 3 kilometers wide. Imagine that. An object as massive as our star, squeezed into the size of a small city. But that's just the beginning. Because some black holes aren't small. Some are so big, so massive, that our minds recoil from the numbers. They aren't just massive, they're monstrous. At the heart of our own galaxy lies one of these giants, Sagittarius, a star. It's 4 million times more massive than the Sun, and yet, compared to others, it's tiny. In a galaxy far beyond ours, a black hole waits inside home, 15A, 40 billion times the mass of the Sun. It weighs more than half the stars in the Milky Way put together. A dark god sitting quietly in the heart of a galaxy 700 million light-years away. Its size, big enough to hold our entire solar system. And still, it isn't the largest. Not even close. Because further out in the direction of the constellation, Canes Venatici, a light pierces through time. It's not a star. It's not a galaxy. It's a quasar. A brilliant, furious beacon, brighter than 140 trillion suns. So bright, it outshines the galaxy it lives in. That quasar is called TON 618, and at its heart is the most massive black hole we've ever found. 66 billion solar masses. Let that number settle in. A single black hole, heavier than everything in the Milky Way combined. Its diameter? Nearly 390 billion kilometers. Light from TON 618 takes over 10 billion years to reach us. That means we're seeing it as it was when the universe was just a child, barely forming. And even then, it had already become this colossal monster. So how does something that big come into being? Some think it started with smaller black holes merging, one by one fusing together over eons, swallowing stars and gas and even other black holes until nothing could rival it. Others think there was once a seed, something unlike anything we've ever seen, that grew not by feeding but by exploding in mass from the very start. But no one really knows, and maybe that's what terrifies us. Because if something like TON 618 can exist, if something that massive can form so early in the universe, then what else is out there? What haven't we found yet? We used to think black holes were the end, that once something fell in, its journey was over, a full stop, a cosmic goodbye. But now we know the truth is stranger. Because even black holes die. Not loudly, not suddenly, but in the quietest, slowest way imaginable. Over time, trillions upon trillions of years, they begin to evaporate, fading not with a scream, but with a whisper. It's called Hawking radiation, a ghost-like process where black holes slowly lose energy by releasing particles at the edge of their event horizons. It's not much. A black hole with the mass of 100 million tons would take longer than the entire age of the universe just to lose half its weight. But it happens, and the bigger the black hole, the slower it dies. So the monsters we found, the Holmes, the TON 618s, the ones swallowing galaxies and lighting up the night across time, they will be the last things to go, long after every star has burned out, after every planet has frozen, when galaxies have thinned into lonely embers drifting through darkness. The universe will grow cold, and still black holes will linger, alone. Imagine it, a cosmos with no light, no warmth, no structure, just black holes silently orbiting nothing. And even then, after all of that time, they too will vanish. And when the last one finally fades, there will be nothing. No particles, no stars, no space or time as we understand it. Just a vast, eternal silence. But here's what no one tells you. We don't know for sure that it ends like this, because every time we learn something new about black holes, they challenge us. They flip the rules, twist the laws of physics, force us to reconsider what we thought was solid and real. They are the universe's greatest illusionists, hiding secrets deeper than we can imagine. Some scientists believe there may be a new class of black holes, even more massive than anything we've seen so far. They call them stupendously large black holes, a name that sounds like science fiction but is entirely serious. These could have masses over 100 billion suns, or more. And maybe they already exist. Maybe we haven't seen them because we haven't looked in the right way, or in the right time. The light from the early universe is still arriving, still crossing the ocean of space to find us. And when it does, it might show us something impossible. Because the truth is, we've only just begun to understand what's out there. Our tools are young, our knowledge is young. And black holes, they are ancient. They've been waiting since the beginning. Maybe some even formed before the first stars. Maybe there are black holes from before time. But we don't need to go that far to feel their pull. They already haunt the edges of our understanding. They already live in the skies above us, in the shadows of galaxies, in the hearts of quasars, in the soft ripples of space-time we've just begun to detect. The more we look, the more we find. And the more we find, the more we wonder. What are they hiding? What lies beyond the veil? Are they prisons, pathways, reflections? Do they tear the universe apart, or stitch it back together in some higher logic we can't yet grasp? All we know is this: a black hole is not just a hole in space, it's a crack in reality, a doorway, a mirror, a promise, and maybe, just maybe, it's also a beginning. If you enjoyed this journey into the unknown, if black holes ignite your curiosity the way they do ours, don't forget to like, subscribe, and share this with someone who needs a moment of cosmic wonder. And let us know in the comments what you think lies beyond the edge of a black hole. Until next time, keep your eyes on the stars and your mind open to the dark.